This presentation is going to help you with the scientific method for this year. You're going to use it to help you fill in the foldable we made in class. Here's a diagram of what your foldable should look like on page 16. As I write down the titles, please write them down on your foldable in the same way that I am. On the top of the first flap, please write the term scientific method. When we get to the next slide, you're going to see a definition that you're going to put underneath there, or on there. On the next flap, it should be a different color, you're going to write the term question and slash problem. The next one is hypothesis. The next one is experiment. The next one is data analysis. And the last one is conclusion. So what is scientific method? It's a way to answer questions and problems that we come in contact with in the world around us or in our daily lives. This part in the white is what you're going to write on the top flap of your foldable. If you look at this picture, the picture is of a man who's trying to come up with a way to make it easier for him to brush his teeth. It's a problem that he has, but it's also a problem that we come in contact with in our daily lives. Flip up to the question problem flap. The information that's on this slide is what's going to go on that flap. In dealing with the scientific method, you have to ask yourself a couple of questions. So you have to ask questions about something that can be observed. These questions are something like why, how, or what. So if you go back to why, it says why does it rain? You can observe that it's raining out, but you want to understand why does it happen. You want to understand how the sky is blue and what causes metals to rust. So these questions are all questions that can be observed. It's important to understand all of these questions are questions that can be solved. So I'm going back to our picture with our guy who wants to brush his teeth. He has a problem. He wants to find out what's the easiest way for him to get the toothpaste on his toothbrush while doing other things. Okay, and flipping up to the next flap, you're going to go to the flap that says hypothesis. A hypothesis is simply an educated guess or prediction about how things work. And this is where you want to use an if-then statement. So I gave you guys an example. If I do this, then this will happen. So if we take a look at the picture of the boy and what he's created, his car, we want to make a hypothesis on maybe how far it goes by saying if I make larger wheels on my car, it will go farther than the other cars. Can you make another hypothesis? Now go to the experiment section of your foldable and flip up the tab. When you run an experiment, you're actually testing your hypothesis that you came up with. When you run that experiment, you'll find out if your hypothesis is right or if it's wrong. Don't worry if it's wrong. An important point to remember when running any experiment is that you can only change one thing at a time in an experiment. It's important to know that because if you change two things, you're not going to know what actually changed the experiment itself, and you won't have valid results. You need to conduct several tests to make sure that you're correct. I say this because if you run one test and the results are kind of skewed and kind of what you didn't expect, and you kind of go with that, you don't really have valid results. So if you run a couple of tests, you'll kind of see, oh, maybe I messed up something on that first test, but the other 4 say that my results should be around this certain number. And finally, record your data/findings in a data table. This will allow you to visually see what your findings were for your experiment. In looking at this picture, what kind of experiment do you think this person ran? Do you think that his hypothesis might have been correct or incorrect? What kind of data could he have collected from this picture as well? Flip up to the data analysis flap. Here is where your data needs to be presented in a visual way, such as a graph. It's important to look for patterns in your graph. This way you know where your experiment might have gone the way you thought it should go, or where it might have gone a way you didn't think it should go. This is just an example of somebody's data analysis with different types of fertilizers for an average height of plant. Flip up to your final tab. That should say conclusion. The conclusion is the very end of your experiment. So here's where you're going to review your hypothesis and see if your data proves if your hypothesis is correct or incorrect. Your data is going to show you if what you said in that if-then statement is right or wrong. If your hypothesis is incorrect, you're going to come up with possible reasons for the differences between your hypothesis and the results. In conducting your experiment, you can probably tell where something may or may not have gone wrong. If we go back to our guy one more time, kind of look at our conclusion for him. Is the toothpaste going to hit the toothbrush? It looks like it is. So after he does it a couple of times, he can come up with this conclusion if his hypothesis was correct or incorrect. This is the kind of method that we're going to kind of think through our projects this year. And obviously the scientific method does not have to apply to everything in a science classroom. It's around us all the time, and we do it every day and we don't even think about it.